Hello, everybody. My name is John Barad. I am Vice President of Business Development at Velodyne LiDAR. I focus on new partnerships and new market activities, and excited to be here today and share a little bit more about some of the things that we're doing with respect to LiDAR and how they're affecting new markets and changing business operations and business objectives in a number of areas. With a primary focus today, we'll really focus on smart cities and aligning with our new solution called the Intelligent Infrastructure Solution. But real quick, a little bit of background about Velodyne and who we are. We were founded in 1983, building acoustic speakers. David Hall, a brilliant inventor, invented the modern day LiDAR for DARPA Grand Challenge in the early 2000s. And ever since, we have been investing in and building LiDAR to power a number of systems. We last year went public on the NASDAQ, and we've got a few hundred employees and are a global company. But for those who don't really know what LiDAR is, I'll take a step back and give you a little bit of understanding. LiDAR, in effect, is basically you can think of it like a laser-based radar, if you will. A LiDAR sends light. This is laser light. It's invisible, eye-safe, and skin-safe laser beams out into the world, and basically paints the environment with this light. Hundreds of thousands, millions of points of light per second are emitted from a typical sensor. That light bounces off of objects, and the sensor measures how long it takes for the light to return, which then, because we know the speed of light, gives us a very accurate, precise measurement of range. And so as a result, we can create real-time 3D models of the environment with a very high degree of accuracy, which is obviously makes a lot of sense, very helpful for autonomous vehicle applications. Cars need to know where everything is at all times in order for them to be safe and maneuver correctly. But LiDAR is also becoming a critical sensor in a number of different applications and areas, not just autonomous vehicles or ADAS applications, but mobility shuttles, public utilities. These are some automated street sweepers here that are awesome and fun to look at. Drone applications, clearly mapping with drones and other applications from the sky. Defense industries, military industries are automating very aggressively. Industrial applications like farming and are utilizing capabilities to automate and help scale up their operations. Down here this is a security robot from a company called Nightscope that has developed an automated security solution that roams around airports and parks and malls and provides the ability to monitor if there are issues and alert authorities to provide assistance if needed. Mapping is a big area where LiDAR is used to produce very high resolution maps for all types of applications, whether it's AR, VR, or your Google or Apple Maps, AR, VR applications. This is an exciting area, certainly. And here, last mile delivery. These are outdoor robotic applications. Are gaining a lot of ground and interest and speed. But from a fixed position standpoint, we call this smart city applications. All these others are using LiDAR in mobile applications attached to robots and such. But Smart City uses it in a different way, very similar capabilities, but just in a fixed position. And I'll talk about that a bit. Velodyne we have a wide variety of LiDAR products, and they range from our Alpha Prime, which is our high resolution LiDAR, 128 channels, down to a 32 channel rotating LiDAR, a 16 channel rotating LiDAR, which are the Ultra Puck and the Puck. And we have a new directional LiDAR family called Veloray. We've got two sensors in that family. And our Velobit, which is not pictured here, but even smaller, very similar in the family of directional LiDARs. And so as you can see, it's really not a one size fits all type of model in our space. LiDARs come in different shapes and sizes, different fields of view and range and resolution. And so depending on the application, that is, there's a LiDAR that could be a fit. So in the field of the smart city field, we have a new solution called the Intelligent Infrastructure Solution. And it's gaining a lot of speed, gaining a lot of ground and a lot of interest in the space. And there are a number of applications where LiDAR can be effective. Essentially, a smart city, if you will, is really a collection of a number of different applications and different connected sensors within a municipal setting that are all talking to and communicating with each other. Initially, our application is highly targeted on traffic management, as that's an area where there's a great deal of need and focus. Although we do have projects in all of these areas that are ongoing around the world. The benefits of LiDAR specifically in this space, ITS stands for Intelligent Transportation Systems, is one, LiDAR, as I mentioned earlier, is an active light source. So what that means is it doesn't require any additional lighting in order to work like a traditional IP camera does. And so LiDARs work really great at night in dark environments where there is reduced light. In addition, because of the resolution that LiDAR has and the centimeter level accuracy of measurement points that we create, we're able to classify all types of road users, all types of objects, pedestrians, scooters, bicyclists, cars, trucks, buses, you name it. And that gives us the ability to create this multimodal system that can take into account all types of vulnerable road users. LiDAR also is very efficient in that because of the range, we're able to utilize a single sensor for to cover an entire intersection. With inductive loops or coiled loops that are buried underneath the pavement, you may need almost a dozen cameras. You may need a half a dozen cameras to do the same thing. And similarly with respect to radar, radar doesn't really have the resolution to identify small objects at large distances necessarily. So certainly a number of radar are needed, but with LiDAR, a single sensor can cover the entire intersection. Back to this slide. Our systems are connected through LTE or 5G or Wi-Fi, as well as obviously a wired connection, which really gives the ability to have a lot of capability, flexibility in how we architect systems. And I'll talk about these systems. But I do want to touch on privacy here a little bit as well, because we're entering, or we probably already are in a world where we're starting to see much more sensitivity to our privacy needs. GDPR in Europe has certainly restricted the use of camera technology in smart city applications. It's starting to be discussed and enacted on here in the US, with, I think maybe it's almost a dozen different states have stopped using facial recognition for law enforcement work. There was a bicameral bill last year in the House and the Senate that hopefully get picked up. Didn't pass yet, but hopefully get picked up in this new Congress to discuss what to do about facial recognition. Even some states don't even allow for speed cameras to be put up. So, the idea of putting cameras up everywhere to provide these analytics is concerning to many people. But as you can see, LiDAR doesn't really provide the same type of information that would be needed to do any facial recognition. And so there's a lot of advantages in that. I think the reason that this application is getting attention in the traffic management space initially is, I think we're all aware of the problems with traffic. Perhaps they've decreased a bit because of COVID, but there's still incredible amounts of inefficiencies. Traffic causes inefficiency in not only just your time, but in there's costs that congestion brings about through fuel efficiency. Most fuel is burned during congestion traffic events. In addition, there's over 1 million people are killed every year on our roadways, and it's highly dangerous. And so having more automation, having ability to better predict and improve efficiency, reduce congestion will certainly help us improve safety. And the sensors that are out there today, or the equipment that's out there today, is decades old and just not very intelligent. The equipment is expensive, really, just focused on a limited set of users of the road, like vehicles. That's all a inductive loop monitors is a vehicle. And obviously, some certain technology, as I mentioned, doesn't really work in all lighting conditions or weather conditions, and there's certainly no analytics. If a city wanted to analyze the safety of an intersection today, the only way to actually do that is to look at the police reports and analyze the accidents. That's a very reactive way to look at safety. And so I think across the board, there's costs that can be and efficiencies and value that can be contributed to smarter infrastructure, and congestion and pollution, and safety. From a cost perspective, though, you might ask, and certainly think that in the past it's been a concern that LiDAR is expensive. Well, the good news is that the cost of LiDAR is coming down dramatically. It already has come down dramatically. We're ramping up production of our sensors. Velodyne is the largest producer of LiDAR in the world today, and we have scaled manufacturing of our sensors, and we're very excited about that for across our product line. And as a result, that brings down the cost, that improves ruggedization and robustness of the sensor, which is an important thing when you're looking at the type of sensor to buy. But when you think about it from a standpoint of the system solution, the total cost of the solution, you might say to yourself, well, cameras are cheap. Well, when you need a half a dozen cameras or a dozen inductive loops to outfit an intersection with a smart safety application or intelligent application, it becomes an expensive proposition. I mean, some of the most expensive items within any type of smart city or fixed infrastructure deployment is the cost of the electronics, the wiring needed to run those sensors. But because the range and the resolution of LiDAR, we can outfit an intersection with a single sensor, as I mentioned, which really reduces the overall efficiency cost and improves efficiency. And so there's a number of applications that we're focused on, and we have projects going up in every single one of these bullets here. There's traffic analytics and studying traffic, near miss monitoring, congestion studies, and I'll talk about some of those. Traffic efficiency improvements as well. We're connecting this solution to light signals to improve timing of lights, ramp metering, crosswalk monitoring, even wrong way detection. And we've got a number of projects in the V2I space. So, as we begin to bring connected vehicles into our world, the importance of having information from an intersection in real time ahead of when that vehicle plans to get there can be very important for path planning, or just to inform an upcoming bus or shuttle of how many passengers are waiting at the traffic stop or the bus stop. And obviously emergency services is an area that's so important. Getting paramedics, or police, or fire to a scene of an accident as quickly as possible can, any reduction in time can save lives. So what does a LiDAR see? This is our VLP32, our Ultra Puck. It's a 32 channel LiDAR. And it looks like we're kind of really high up, a bird's eye view, but really what this sensor is about maybe 10 meters off the ground, 10 to 15 meters off the ground. And we've created a real-time 3D model of this environment, so we can move around and scroll around within the scene. But this is raw LiDAR data. You see each white line is a new laser channel that is emitted, and you can see all the way down the approaches of the intersection, which give it full coverage. If we then layer on top of this the perception layer, you can see we can start to classify and track all types of objects. We're classifying cars in red, and there goes a motorcycle in dark blue, and we've got pedestrians in green. Really provides, as you can see, a lot of detail on them. And even in addition, we can create geofence perimeters around certain areas, like crosswalks, and monitor who's in the crosswalk, what direction they're going, how fast they're moving. Here we have also some virtual coiled, virtual loops, we call them, which are basically geofence perimeters around where a coiled loop would be, or an inductive loop would be. We can count cars. We can really just a rich source of analytics and data here to be able to integrate all types of really exciting applications. How fast is the car moving? What direction? The trajectory? Which turning movement are they making? And really, another really important one is, how close are they coming to other types of road users, which is important in understanding and analyzing the near miss activity. Our platform is powered by an NVIDIA Jetson processor. These are really great compact, low power, edge-based processors, and we run the analytics. We run our software at the edge. Here's a kind of a representation of a system that's connected to a light pole, where we have the edge box, and it's connected up to the LiDAR. You can put this edge box on the pole itself or in the traffic closet, just depending on where you want it. And so the solution is a full end-to-end solution that combines all of these elements. Once the data is processed at the edge, we then send the analytics up to a cloud application that enables us to do all kinds of slicing and dicing of the rest of the data for analytic purposes and for reporting. And we also have an API that can be integrated into various applications. And so we have a number of projects that are going up around the country. This is just a few of the ones we could talk about, but there's a bunch more that we will be announcing soon. A very exciting one with New Jersey Department of Transportation, where we're in conjunction with Rutgers University, we'll be putting up, I think it's over a dozen different intersections with our Alpha Prime sensor to monitor all types of new smart city applications and mobility applications there in New Brunswick, New Jersey. I mentioned kind of the coiled loops. This is, I guess, a really good use case to, coiled loops are costly little things that break all the time. You can see them. They're like they're dug into the pavement when you go to an intersection. All they do is count cars. Not very sophisticated, not providing a lot of fidelity, but our solution can enable that. Speed analysis, as I mentioned, here's a view of some of the screens, reports that you can create through the application to monitor speeds of vehicles as they go through an intersection. You can even get as granular as to just monitoring speeds of a particular direction at a particular time of day within the intersection. Near miss collision analytics is something really exciting. As I mentioned earlier, really the only way to monitor collisions today is to look at police reports. And that is something that we need to have a more proactive solution. And so we look at what's called post-encroachment time, which is basically the time difference between when two objects paths, when their paths would intersect. And the time between those is a PET value, a post-encroachment time value. Typically, under 2 seconds is pretty unsafe PET value. And so identifying where those are within the intersection can be really important. And here is a little video showing a pedestrian crossing the street here, and with a vehicle that's turning right. And that event, it has a very small, less than 2 second post encroachment time. And so we can start to analyze that and look at the trends and understand, is this happening a lot within this intersection? And if so, we can start to make some proactive changes before somebody actually gets hurt. And so in the dashboard, we have an interactive heat map where we can look at all these different types of interactions between road users and do some analysis as to what is the the biggest issues that are outstanding, and understand within the user interface there, get a sense of where some of these issues might be, and what some of the dangers are. I'll finish with a look at our high resolution sensor. This is our alpha prime sensor that we put up in a number of areas, including the New Jersey DOT project I mentioned. And as you can see, this is even higher resolution than what we typically put up. This has these sensors have each laser channel has a 300-meter range. It's just beautiful resolution. You can see really far down and start tracking the Q length very well. And very exciting sensor here that has a lot of uses. 128 channels, as I mentioned, as well. And here's a little demo that shows kind of the range with our tracking on top of it. You can get a classification range of over 200 meters here in total coverage with this sensor. So exciting applications there, certainly. Well, so I think I'm about out of time, but I certainly appreciate the opportunity to share more about this solution, how it's changing the infrastructure landscape and some of the applications that we're working on. And please feel free to send me an email and let me know if you have any questions or would like to learn more. Thanks so much. Bye-bye.